designed to shoot down Soviet bombers. Now a trove of declassified documents reveals the audacious mission to build a flying saucer. September 2012, Michael Rhodes, who was a technician at the National Declassification Center, NDC, in College Park, Maryland, put on his white gloves, entered a climate-controlled room, and opened a cardboard file box because it was time for a report inside. Project 1794, Final Development Summary Report to April to 30th of May 1956, to become public. Rhodes' job is to read these type of documents, catalog them, and make them available to historians, journalists, and anyone who's curious to find out what's in these declassified reports. The paper was crisp, like new, and Rhodes began to read. He soon realized that the file box contained highly unusual material. He said, "As I was processing the collection, I glimpsed this weird red flying disc icon in the corners." Rhodes went on to say, inside the box was a trove of oddities, cutaway schematics of disc-shaped aircraft, graphs showing drag and thrust performance at more than Mach 3, black and white photos of frisbee shapes in supersonic wind tunnels. The icon was a flying saucer on a red arrow, the insignia of a little-known and strange sideshow in aeronautics design. Rhodes was leafing through the lost records of a U.S. military flying saucer program. A Canadian aviation firm began developing a disc-shaped aircraft for the U.S. military in the mid-1950s. And though the details were secret, the project itself was not unknown. Popular Mechanics mentioned the Air Force's vertical rising high-speed craft in 1956, and it even published a photo in 1960. In the decade since the program was cancelled in 1961, aviation buffs and UFO researchers unearthed technical papers written near the end of America's flying saucer experiment, but the document that originally convinced the government to invest in a military flying disc has languished in the NDC under the secret designation. This recently discovered report describes in previously unknown detail how aviation engineers tried to harness what were then cutting-edge aerodynamic concepts to make their improbable creation fly. The flying saucer, that is. Although Avro's saucer never completed a successful flight, some of the most sophisticated aircraft flying today adopted many of those same technologies. 2001, U.S. Air Force personnel cleared the document cache for public release, according to Neil Carmichael, who is the director of the Declassification Review Division at the NDC, which is run by the National Archives and Records Administration. But it took 11 years to crack open the boxes and glimpse the saucer secrets within. The staff is buried in a backlog of nearly 2 billion pages of declassified material, some of it dating to World War II. Carmichael says, "These records probably have been classified since their creation. It's like somebody emptied out a filing cabinet, stuck it in a box, sealed it, and sent it off to the Federal Records Center." In pop culture, flying saucers are the ride of choice for extraterrestrials. What the newly released documents show is that they actually came from Ontario, Canada. That's where a visionary aeronautical engineer at the now defunct Avro, Canada, convinced his bosses to support the unlikely project. Carmichael says, "During the Cold War, the Army, Air Force, and Navy were experimenting with all sorts of things. As the NDC released its declassification documents, the records are going to tell the rest of the stories, and the most sensational of the disclosures so far is Project 1794. Avro Canada hired John Jack Frost in 1947, tapping the 32-year-old for a program to develop a supersonic aircraft called the Avro Arrow. While working on the Arrow program, John Frost that is, conducted experiments in the Avro labs on the way airflow tends to stick to gently curved surfaces, a phenomenon called the Coanda effect. The results show that the engine exhaust could be routed across the fuselage to the area just beneath the saucer, where it would form a cushion of air on which the aircraft could hover. Palmero Campagna, an author and engineer with the Canadian Department of National Defence, wrote a book about Avro called Requiem for a Giant. Frost believed that the Germans had developed some form of flying saucer-like aircraft, he says. Part of that belief stemmed from stories and newspaper articles that appeared back in the 1950s. The stories turned out to be bogus, but they seemed reasonable, and during World War II, Hitler's engineers had outpaced the Allies in developing ballistic rockets and jet airplanes, and those advances had become spoils of war exploited by both the Soviet Union and the United States. Frost worried that equally important flying disc technology could have been secretly taken away by Moscow. Campagna says he didn't want North Americans to lag behind. After Frost talked up the results of his lab research to Almond Soland, the head of the Canadian Defence Research Board, the government official introduced him to decision makers in the Pentagon. Then, as now, the big money in military contracting was, of course, in the United States. The American military was seeking a supersonic aircraft that could take off from primitive airfields to intercept Soviet long-range bombers. And by 1955, the United States was ready to fund a $1 million feasibility study. Aviation historians say they aren't surprised that the concept, which seemed outlandish today, had proponents at the time. Russell E. Lee, who is the curator at the Smithsonian National Air and Space Museum, Washington, D.C., says, "The flying saucer configuration offers benefits. It's totally symmetrical, so in theory it should be omnidirectional if you can figure out how to redirect the thrust in an instantaneous and efficient manner. Putting myself in the shoes of the designers in the early 50s, I would think it would be a viable candidate for further investigation." Frost's design was detailed in a 117-page report, the same document that ultimately was unearthed by the NDC, the declassified papers. The proposal craft featured a central turbine, called a turborotor, powered by 6 turbojet engines. The turborotor sucked in the air that was directly through the body of the aircraft. The exhaust exited from vents placed along the circumference of the aluminum saucer. Vanes and shutters directed the exhaust towards the ground to hover. The engineers predicted that the 20,000 pounds of thrust produced by these jets' exhausts could be directed downward all around the disk perimeter. This jet-around wing configuration produces a powerful takeoff ground cushion, so that the lift on the aircraft is increased to possibly 30,000 pounds, the report says, and the aircraft rises to about 20 feet. Once in the air, the saucer's pilot would reroute the exhaust to one side of the craft to move laterally. The documents reveal the extravagantly rose-colored aspirations of the researchers. Jack Frost predicted the saucer would travel at Mach 4 with a ceiling of over 100,000 feet and a maximum range of about 1,000 nautical miles. The Air Force and Army agreed to fund prototypes, and Avro had Frost set up a secret facility for construction and testing. The Special Projects Group, SPG, was located at the Avro plant in Moulton, Ontario, northwest of Toronto. Avro Canada, which employed 14,000 people at its height, spread its operations over several large buildings and empty lots and aircraft hangars. Today, the location is adjacent to Toronto's Pearson International Airport. Frank Harvey, current president of the Aerospace Heritage Foundation of Canada, worked on an Avro aircraft assembly line from 1956 to 1959. He was not part of the SPG and recalls wondering what was going on within its walls. He says, "Very few people got in there. If you walked anywhere near, there were security guards, of course." The precautions were well founded because Soviet-era notes from the KGB war, a major named Vasily Mitrokhin confirmed that a spy did in fact operate at the Avro facility, seeking information on the Arrow program. Campagna says that the Royal Canadian Mounted Police discovered the spy's identity but never disclosed the name. Jack Frost was the only engineer in the early 1950s trying to master the use of unconventional shapes for high-speed flight. During that era, engineers with the National Advisory Committee for Aeronautics, the NACA, were conducting tests of re-entry space capsules. Vehicles that come from space to land on Earth must be designed to fly at a wide range of speeds and slow from hypersonic to a standstill. Avro's saucer, of course, was not intended to reach space, but it did have a flight profile similar to that of a re-entry capsule. Frost and NACA came to this conclusion. Rounded shapes fared best. Robert Brown, a Georgia Tech professor of space technology who served as NASA's chief technologist from 2010 to 2011, says this configuration provides two main benefits to high-speed craft. He says, if you wanted to go to supersonic speeds, heat is something you're going to have to deal with. Bowl-like shapes dissipate heat, and this same shape provides predictable aerodynamics through all of those speed regimes. From below, the Apollo capsule looks like a flying saucer. In the Pentagon, hopes ran high for the Avro program, and Bernard Lindenbaum, an honorary fellow of the American Helicopter Society, the AHS, who died in 2002, participated in the flying saucer program as an Air Force officer. In a paper for the AHS, the American Helicopter Society, he recalled a Washington, D.C. meeting that he attended in the late 1950s to secure research money for the UH-1, the Huey helicopter. After his meeting, he overheard an Army general remark that the Huey was to be the last helicopter the Army would buy. It's replaced, according to the general. Avro's saucer. November 1959. The high-pitched scream of three turbojet engines filled the air of an industrial park at Avro's headquarters. Test pilot Vladislav Potocki, Spud for short, pulls back on the controls, the control stick, and the 18-foot wide flying saucer lifts off the ground, blasting snow and ice across a vacant lot. It is a miniature of a larger craft envisioned in Frost's study. While the final version will have 6 engines, the prototype now undergoing testing has only 3 engines. The test occurs in the space between 2 buildings away from prying eyes. Potocki had received the British designated Flying Cross in World War II, but he also tested the Avro Arrow. Now the company has assigned him to pilot the Avro car, their 5,680-pound flying saucer, for its first flight independent of a 3-cable tether. Getting off the ground is easy. Then it happens, as it always does. When the saucer rises above its 3-foot cushion of exhaust, it starts to buck like a rodeo bull. The researchers are crestfallen. They've seen this instability before. They call it hubcapping, after the circular way or car hubcap oscillates on its rim when dropped on hard ground. Potocki aborts the flight and sets the Avro car down. Over the years, the engineers would test wide-ranging methods to control their craft. Shaped nozzles, spoilers, skirts, bigger engine transition doors, vanes, even at the suggestion of the Air Force, and to Frost's dismay, a tail. But nothing worked. The Avro car never achieved stability in the air, and it never traveled faster than 30 knots or higher than 3 feet. So much for the intercepting bombers. Despite its brief triple engines, the Avro car suffered from a lack of power. As the airflow snaked through the saucer, it lost potency. They didn't understand the fluid dynamics, says Jeff Underwood, the historian of the National Museum of U.S. Air Force at Wright-Patterson Air Force Base in Ohio. He says, The thing probably had plenty of power, just that all of the thrust was being bled off in friction. As it was trying to push the air around, it was all being wasted. Still, Avro was onto something. While Frost was engineering his saucer, a French airplane designer named Michael Wiebold was also exploring aircraft steering by redirecting their exhaust. His concept for a fixed-wing fighter, the Gyropter, relied on 4 turbofans to take off vertically. His research would, by the late 1950s, form the foundation for the British Harrier jump jet. The engineers who created the Harrier found that swiveling the exhaust nozzle itself was more efficient than redirecting the airflow. This concept survives in modern aircraft. The F-35B Lightning II rotates its exhaust 90 degrees to take off and land vertically. Main missiles and the F-22 Raptor warplanes steer by angling their engine nozzles. That's how the F-22 makes such sharp, high-speed turns, says Underwood. Engineers today can design very maneuverable but aerodynamically unstable aircraft and expect computers to keep their creations airborne. Flight control processors translate pilot instructions from the control stick to make countless adjustments for the engine nozzle and flight control surfaces. Brown says, we're at the point with digital control, you can fly anything. You can take a brick from a garden and make it fly. Ironically, one of the first production aircraft to use electronic signaling to flight control surfaces, called fly-by-air, was the Avro Arrow, but the Avrocar team never tried to adopt the idea. If the power issues could have been solved, such a system might have steadied the saucer's unstable flight, but instead Frost sought a purely mechanical solution, and that's why he failed. Now for the saucer's requiem. The U.S. pulled the plug on the Avrocar in 1961. Jack Frost left Avro and moved to New Zealand to design innovative aircraft for that nation's airline. He never lost his drive to innovate. After retiring, he worked with local university students to design human-powered aircraft. Frost died of a heart attack in 1979, his visions of flight unrealized. Spud Potocki went to the United States, joined Rockwell as a test pilot, and retired in Ohio, and then died in 1996 at age 77. For its multi-million-dollar investment, the U.S. military kept the 2 Avrocar prototypes. One is stored disabled in crates at Joint Base Langley, Eustis in Virginia, under the custody of the U.S. Army Transportation Museum. The Air Force prototype ended up in the care of the Smithsonian, where it sat for decades as a behind-the-scenes oddity. Then, in 2007, the National Museum of the U.S. Air Force at Wright-Patterson Air Force Base asked the Smithsonian for the aircraft in a swap. The Air Force flew the prototype from Washington, D.C. to Wright-Patterson inside a C-5 Galaxy transport plane and trucked it to the museum. A restoration team fabricated pilot canopy bubbles, crafted seats, and touched up the rusted areas, and in 2008, after a lifetime in the shadows, the Avrocar was ready to be shown. Museum staff used Avro saucer in lessons about vectored thrust, with the Avrocar playing the role of a technologically dead end. But dead ends count for something too. Dave Lazarine, a restoration supervisor who worked on the Avrocar, says engineers at Wright-Patterson come to the museum for inspiration, to get a feel for what people were doing back then. They are always trying to invent something that doesn't exist. Engineers know that aviation is an evolution, and understanding the risky dead ends is as important as admiring the successes. I'll leave a link below for you for this. This is on Popular Mechanics by Joe Papalardo.